this video, we are going to solve example of convolution sum for infinite sequences. So, first of all, let us write the equation for convolution sum given as y of n equal to x of n convolving with h of n. X is the input signal, h is our impulse response. So, it is represented as summation k equal to minus infinity to plus infinity x of k into h of n minus k. So, to find out y of n, we need to make use of this equation, and in this equation we have x of k and h of n minus k. So our first task is to represent x of n in terms of x of k. To obtain first, so we need to have x of k. From the given equation, x of n is given as u of n. Therefore, x of k will be equal to u of k. Now we know that this u of k is nothing but unit step signal. So this unit step signal is drawn for the positive axis with amplitude equal to 1, and it lies at the integer values. Therefore, we can represent this equation x of k as it is 1 for k greater than equal to 0, which is the base equation for discrete unit step signal. Secondly, we have to obtain h of n minus k. So second step, we need to obtain h of n minus k. So originally we have h of n equal to 1/2 raised to n into u of n. So first of all, we need to find out h of n minus k. Here h of n minus k will be equal to 1/2 raised to n minus k into u of n minus k. So if we find out the representation of u of n minus k, it is folded and shifted version of the unit step signal. So if we draw this signal, so in above case we have this u of k. This u of k signal will be folded, so it will be towards left hand side, and if we shift it by k, it will again shift to left hand side, so it will be in this way. And these samples will be starting from n. It will be n, n minus 1 and so on with amplitude equal to 1. So this equation can be written as h of n minus k equal to 1/2 raised to n minus k into 1, u of n minus k is 1 for the value of k less than equal to n. So here you need to find out these limits carefully. So for first case, k greater than 1, k greater than or equal to 0, so it as the input was a u of n, so easily we have obtained the limit of k as greater than or equal to 0. But for the upper limit, using this equation u of n minus k, we have to carefully obtain the limits of k. So this u of n minus k is 1 for k less than 1. So this can be easily seen from this particular diagram. Now we have obtained x of k as well as h of n minus k. Substitute this in this equation of y of n. So y of n becomes the original equation, k equal to minus infinity to plus infinity x of k into h of n minus k So from above two cases, we have the limits of k equal to k is greater than or equal to 0 and less than n. For these limits, x of k is 1 and h of n minus k is 1 by 2 raised to n minus k. So we have to evaluate this summation. Which is equal to now summation equal to 0 to n 1 by 2 raised to, this n minus k can be written as n into 1 by 2 raised to k. Now this summation is with respect to k, so we can take the n term out of this summation and we get summation k equal to 0 to n 1 by 2 raised to k. Now for this standard summation, we have an equation, a standard identity of summation, which says that if we have summation from n1 to n2 a raised to k, it is evaluated as if a is equal to 1, it is n2 minus n1 plus 1, and if this a is not equal to 1, we have a raised to n2 minus a raised to, so it is not n2, it is a raised to n1 minus a raised to n2 plus 1 upon 1 minus a. So if we use this formula, so with this equation we can find out the final solution. Now this 1 by 2 in our equation of y of n, 1 by 2 raised to k, 1 by 2 raised to n will be as it is, and this summation, in this summation our capital A is 1 by 2, so we have to use the second condition, a not equal to 1, so it becomes 1 by 2 raised to n1 is 0 minus 1 by 2 raised to, or n2 is n plus 1 divided by 1 minus a, which is 1 by 2. So if we simplify it, we get 1 by 2 raised to n as it is. In this bracket 1 by 2 raised to 0 is 1 minus 1 by 2 raised to n plus 1 divided by, so if we subtract this, so 2 minus 1 1, it becomes 1 by 2. So further it will be 1 by 2 raised to n into 1 minus 1 by 2 raised to n plus 1, and this denominator 2 we can take it out and we can multiply it with this equation. So now it becomes 2 into, I will multiply this 1 by 2 raised to n term inside the bracket, so 1 by 2 raised to n minus 1 by 2 raised to n into 1 by 2 raised to n plus 1. So our final answer becomes, so if I again multiply this 2 inside bracket, 2 into 1 by 2 raised to n minus, now these two terms can be combined together, so it becomes 1 by 2 raised to, it is 2 into 1 by 2 raised to 2n plus 1, and the final answer will be, so here 2 gets cancelled out, it will be 1 by 2 raised to n minus 1 minus, here also 1 2 gets cancelled out, so it will be simply 1 by 2 raised to 2n. So this will be your final answer for y of n. So for infinite sequences, we can obtain y of n using these steps. So this represents convolution sum for infinite sequences. So just to revise, with the given x and h, we need to find out x of k, we need to find out h of n minus k, substitute these two values in the summation and evaluate the summation. You will obtain the desired answer y of n.